Today we are talking about an introduction to chemical reactions. Okay, so chemical reaction, what is it? Basically, it is when you are going from one substance to another. So the proper definition is a chemical change in which one or more substances are destroyed or new substances are created. What you really need to take from this is that it's a chemical change. During a chemical reaction, you are creating brand new substances that might have completely different properties than what you started with. Okay, so in this case, we have H2 gas and O2 gas. They're going through a chemical reaction as indicated by the arrow, and it is creating two water molecules. Hydrogen gas and water are very different, and they have very unique properties, which ensures that a chemical change has happened. So, parts that you need to understand for a chemical reaction, we have the reactants. This is what you put in. This is the before. So these are going to be the ones that you start with, and they're going to be the ones that end up being changed. So here you are breaking bonds, okay? So like in this past example where we had the H2 plus O2 is going to create H2O. Like here there was a bond break, okay? So like that is what is happening with reactants. Your product is what's coming out. This is the new stuff, the new. This is what's being created. Your arrow is what's indicating that a chemical reaction is happening. It's also telling you which way it's going. So you can have it where your reaction is moving this way, and here are your products, and here are your reactants. So you just have to make sure you pay attention to the arrows, okay? Some other symbols you need to keep into consideration. So these are just showing you the state of matter it's in. This is not super important for, like, don't stress out if you started with a solid and you end up with a liquid. That is not concerning matter, okay? Aqueous, this is probably the new one to you. This basically just means it's dissolved in water, okay? Your plus sign in your chemical reaction, so H2 plus O2, is letting you know that there's two different substances. So it's breaking it up almost. And then again, the arrow is just telling you that you're about to have a change. So some evidences of chemical reaction. So if light or heat is released, if there is a temperature change, if gas has formed. So when I think of gas, I am thinking more, give me a second, I'm recording something. Sorry guys. So for formation of gas, more so like if you add two room temperature liquids together and then gas is released, obviously it's not because it's boiling. So boiling would not count. Let's include that. And then a color change as well. And then formation of precipitate. Precipitate, just means it's a new product. So like here you have this clear liquid going into this clear liquid, and it's creating this like yellow substance. That is precipitate. So not so much on your test, but on some of the practices, you're going to have word equations where it's basically just writing everything out. So here we have iron, it's a solid, plus chlorine, it's a gas, and it's going to create iron 3 chloride. How you would read this is solid iron and chlorine gas react, combine, you can say precipitate, produce a solid iron 3 chloride. It's just like a word problem. You would just read it out entirely. Skeleton equations is when you actually use the chemical symbols. So how we had that last equation, the iron solid plus chlorine is going to give you iron 3 chloride. You would write it with the symbol. So iron is Fe, chlorine is Cl, but remember chlorine as a gas is a diatomic element, so it would be 2. And then iron 3 chloride, you would do this from the charge, so that's what the parentheses is letting you know. So iron Fe would have a plus 3 charge, chlorine Cl has a negative 1. You do the swap and drop, and it'll give you FeCl3. Okay? By no means is this balanced, but you get the idea. This is just another example, but now we're talking about coefficients. So coefficients are going to be indicated in red, and they're going to go in front of your skeleton formula. These can change. These are used to make sure that what goes in on one side matches what goes in on the other side, or what comes out the other side. Your subscript is going to be a part of your chemical formula, so that's going to be these letters down here. Okay, so if you remember when we were talking about polyatomic ions, subscripts are super important. So nitrate is NO3, nitrite is NO2. Okay, these are very different elements or different ions. So this 3 cannot change. This 2 cannot change. The only thing that can change are your subscripts. I'm sorry, your coefficients. And then this is just an example of writing reactions. I'm so sorry, someone decided to print right now. Please hold. Okay, and the reason why we balance equations and we have to work with the coefficients is because of the law of conservation of mass. Mass can't be created or destroyed. What you start with has to be what you end with. You can add to it, but what is on one side needs to be on the other. So here in this example, we have H2O2. You have 2 molecules of hydrogen and 2 molecules of oxygen, because that's what the subscript is telling you. And then these are going to create water, H2O. You have 2 molecules of hydrogen and only 1 of oxygen. This is not correct because what happened to this oxygen? So what you have to do is you have to add coefficients to match out. What I like to do is I like to write it at the bottom. So H2 plus O2 is going to give you H2O. I like to list everything out. So I have H, I know I have 2. Oh my goodness. O has 2 again. This side you have H, 2, O has 1. Think of the arrow as an equal sign. So you want to always make sure that they're equal. So you have to basically look at your equation and figure out what coefficient can you add in order for it to be balanced. So things that we are saving and making sure are equal. Your mass, so your mass, your types of atoms. So if you start with silver, you have to end with a silver. You can't just change it to gold. And then the number of each. What we're not concerned about is color, the physical state, volume, number of moles. So all of that can change and it's fine. So some important rules that you need to know about balancing equations. The first thing, change the coefficients, but never the subscript. Never change the subscript. Second one is basically, if you can simplify, do it. So if you look at this, you can easily divide all of these by 2 to make it smaller. So here you would get 2H2O plus O2 is going to give you 2H2O. Here, we did not touch the subscripts at all when we divided, only the coefficients. So like a fraction, you want it in its simplest form. Your third one is if you have a very crazy equation that you need to balance, try to save these at the end, because their hydrogen, carbon, and oxygen are very common, and they're usually used more than once in an equation. So just save yourself the headache and wait till the end to do those. And then finally, just double check your work. You don't want to balance the whole thing and multiply it by crazy numbers and it be wrong. So just at the end, just double check, count it out. So what I would usually do is I would just make sure all my math adds up. So 2 times 2 is going to give me 4 hydrogens. O has 2. And I do the same. 2 times 2 is going to be 4. And then this 2 times this O is going to give me 2. And it all checks out. Okay? So this paper was here for practice for you. It found in the modules. You don't have to submit it, but this is good practice to learn how to balance. You don't have to worry about part A, and you really don't need to worry about some of the coefficients. So what you would do is we just look at this one. So here before the equation, we have 1 carbon, and then we have 2 hydrogens. Okay, then on the other side of the arrow, carbon, we still have 1, but hydrogen, we have 4. So this subscript, this subscript is exclusive to H. If the whole thing was in parentheses and then it had the subscript, then all of it would multiply. But because this one only H has it, it's only exclusive to H. Okay, so we look at this. Carbon matches up. I have one on this side, one on this side. This one's good to go. My hydrogens, here I have 2 and here I have 4. So I would have to think, what do I need to do to this side in order to get it to 4? Hopefully you said you just added 2 here, and that would change this 2 to a 4. And that's all you have to do. And you can just double check it. So here I have 1 carbon, that checks off. Here I have 1 carbon. Here I have 4 hydrogens, here I have 4 hydrogens. If you want, you can put a 1 here, but it's not necessary. Okay, I'm going to erase this so we have some more space, and we'll do a couple more problems. So this one, iron, we have Fe. On one side, there's 1, and on the other side, I have 2. Then I have oxygen, I have 2, and then on this oxygen, I have 3. So what do I need to add on this side in order to give me 2? I just pick one element and we just move from there. And if you have to change it, just go back and erase it. So this iron, I have 1, the other one has 2, so I'm just going to add 2 here. Equals 2, so this side checks off, this side checks off. But on oxygen, here I have 2 and here I have 3. So the closest number that both of them are divisible by, or they're able to divide into, would be 6. You can also do it by just multiplying the 2. So 2 times 3 is going to give me 6. So basically I have to turn this number into 6 and this oxygen into 6 and this oxygen into 6. So we'll start on one side. 2 times 3 is going to give me 6. Okay, and on then the other side, 3 times 2 will give me 6. So here I would put a 2. Okay, so let me erase a little bit of this so I have some space. Okay, so 2, so on one side, I have 2 on this side, so 2 iron. Oh, I have 6, and on the other one, 2 times 2 is 4, and then 2 times 3 is 6. Okay, so here I would have to change it because this does not add up. So all I would do is go back, erase this, and here I have 4, here I have 2. What would I need to do? Just multiply it. Just change that to a 4. And that all works out. Okay, hopefully this is some good practice. I will post the key for it so you can double check your work, and